On the sun-scorched plains of South Texas, Starship stands ready, the largest, most powerful rocket ever built. Its gleaming steel hull reflects the hopes of a generation, and its towering presence dominates the horizon, a symbol of human ambition, reaching for the stars. It's more than metal and fuel. It's humanity's dream of becoming a multi-planetary species. Every bolt and circuit is a testament to our desire to explore, to push beyond the boundaries of our world and seek new frontiers. On August 24, 2025, Starship Flight 10 will ignite, aiming for orbit in a pivotal, high-stakes test. The countdown will echo across the globe, as millions hold their breath, waiting to witness history in the making. This isn't just another launch, it's a gamble that could redefine space exploration. The tension in mission control is palpable, every second ticking by with the weight of possibility. SpaceX is pushing boundaries, testing daring maneuvers and taking risks that traditional agencies avoid. Their engineers work around the clock, innovating at a pace that leaves the world watching in awe. NASA is watching closely. Starship's success is crucial for Artemis 3 and the return to the moon. The outcome of this flight could shape the future of lunar exploration and beyond. For SpaceX, a win validates their radical approach and brings Mars one step closer. Each test is a stepping stone toward a future where humans set foot on the red planet. The world will watch as this metal titan attempts to conquer the sky. From school children to seasoned scientists, all eyes are fixed on the heavens, united by curiosity and hope. But ambition comes with risk. Starship's history is written in explosions and lessons learned. Each fiery setback is a chapter in the relentless pursuit of progress. 3 test flights this year ended with the loss of the upper stage, a reminder of rocketry's unforgiving nature. The path to the stars is paved with trial and error, and every failure brings new understanding. SpaceX embraces failure as part of progress. Each setback is met with determination, fueling innovation and resilience. Flight 10 is a tightrope walk over uncertainty. The stakes are higher than ever, and the margin for error is razor thin. Will it be a triumphant leap, or another necessary setback? The answer will echo through the halls of space history. The countdown begins, and the future of spaceflight hangs in the balance. As the engines roar to life, humanity stands on the edge of a new era, ready to rise or fall with Starship's fate. The journey begins with Super Heavy Booster 16, a towering marvel of engineering standing tall on the launch pad, bathed in the early morning light. This is not just another test flight, it's a bold leap into the unknown, pushing the boundaries of what reusable rockets can achieve. Soon, it will attempt a breathtaking, risky flip high above the Gulf of Mexico, a maneuver that has never been tried at this scale. The world will be watching as the booster arcs over the ocean, preparing for its daring pirouette. Instead of firing its engines to turn around, Booster 16 will rely on atmospheric drag, much like a skydiver spreading their arms to control descent. This innovative approach is designed to save precious fuel, making the return journey more efficient. This radical move could conserve up to 40% of the return propellant, a significant breakthrough that translates directly into more payload capacity for each mission. In practical terms, that means Starship could carry an additional 20 to 30 tons to orbit, potentially millions of dollars in added value per flight, opening new possibilities for commercial and scientific missions. It's a potential game-changer for deploying massive satellite constellations, building a sustainable Mars colony, or sending larger payloads deeper into the solar system. But the risk is enormous. Tilting a 70-meter booster at supersonic speeds puts unimaginable stress on its structure and materials, testing the limits of aerospace design. The control systems must perform flawlessly. Even a tiny miscalculation or delay could send the booster tumbling out of control, ending in a fiery explosion and a setback for the program. This is a high-stakes dance with physics, balancing on a knife's edge between triumph and disaster, where every second counts and every variable matters. If successful, this maneuver could revolutionize rocket reusability and transform the economics of spaceflight for decades to come. If not, it's another lesson in the relentless pursuit of progress, a reminder that every failure brings new insights and fuels future innovation. As Booster 16 attempts this daring maneuver, engineers, enthusiasts, and dreamers around the globe will be holding their breath, witnessing history in the making. SpaceX knows the risks. Booster 14's failed flip ended in a spectacular explosion. That disaster wasn't the end but a source of invaluable data. Engineers dissected every millisecond, learning exactly where the structure failed. SpaceX's philosophy, fail, learn, iterate. Armed with new knowledge, Booster 16 features reinforced structures and a refined, less aggressive flight profile. The goal: achieve fuel savings without exceeding the booster's limits. This is a calculated attempt, not a gamble. Flight 10 will test whether these improvements are enough. If Booster 16 survives, it proves lessons have been learned. If not, it's back to the drawing board. Every flight is a step forward, even through fire. The skies above the Gulf will reveal if history repeats or progress prevails. Booster 16 won't be caught this time, but its return is a step towards SpaceX's boldest goal: Mechazilla recovery. Mechazilla, the giant tower with robotic arms, aims to catch boosters mid-air, eliminating heavy landing legs and enabling rapid reuse. A successful flip and landing burn prove pinpoint accuracy, paving the way for future catches. This could slash launch costs and make spaceflight as routine as air travel. If Booster 16 nails its splashdown, the dream of catching rockets becomes tangible. Flight 10 is a dress rehearsal for a new era of reusability. The future of space access could be transformed, one controlled landing at a time. As if the mission weren't ambitious enough, SpaceX will intentionally shut down one of Booster 16's 3 landing engines during descent. This planned engine-out test proves the booster can survive a real engine failure. The remaining engines and flight computer must compensate in real time for a safe landing. It's a high-stakes test of resilience. Failure means a fiery crash, but success proves Starship can handle the unexpected. SpaceX is willing to risk a multi-million-pound booster for data that will make future flights safer. This proactive approach sets SpaceX apart. They force failures now, not during critical missions later. Success boosts confidence in Starship's reliability. Failure means more lessons, more improvements, and another step forward. The relentless cycle of testing and learning continues. While the booster flips below, Ship 37 faces its own test and in-space engine restart. In zero gravity, propellants float unpredictably, making restarts one of rocketry's toughest challenges. Without this capability, Starship can't reach the Moon or Mars. Past flights struggled with leaks and pressurization failures. Ship 37 carries upgraded systems. Flight 10 will reveal if they work. A successful restart unlocks deep space and proves Starship's readiness for NASA's Artemis missions. Failure means more work ahead, but every attempt brings progress. One spark in the void could change the future of exploration. As August 24th approaches, the world's eyes turn to Texas, where anticipation and excitement fill the air. Reporters, engineers, and space enthusiasts gather, all waiting for a moment that could redefine our future in space. Starship Flight 10 is more than just another test. It's a crossroads for SpaceX and the entire field of human spaceflight. The outcome could shape the next era of exploration. Every phase of the mission, from the booster's dramatic flip to the ship's high-stakes engine restart, pushes the limits of what's possible, demanding precision and courage from everyone involved. Success would not only validate SpaceX's rapid development, but also bring the dream of reaching the Moon and Mars closer than ever before, inspiring a new generation of explorers. It would prove that rockets can be reused like aircraft, slashing costs, opening the door to frequent missions, and enabling dreams that once seemed impossible. For NASA, it's a crucial milestone, proof that Artemis 3 is on track, and that partnerships with private industry can deliver on bold promises. But failure is always possible. A flip gone wrong, an engine-out crash, or a failed restart could turn triumph into setback in seconds. Yet each setback is a lesson, not a defeat. Every failure brings new data, new insights, and a stronger resolve to try again. Starship Flight 10 asks us all, how much risk are we willing to take for progress? How far will we go to reach the stars? As the countdown ticks down, we stand at the edge of history, awaiting either a giant leap forward or the next lesson on the long, challenging road to the stars.